Okay, so I was thinking to prepare a separate playlist for the Python coding practice, and we will explore some lead code problems from time to time. All right. So today, we will explore. So let's go to the problems. We are going to explore the binary search problem, which is very basic. We'll start from basic only. So if we go to the problems and let's search here binary search. So we could see there is a one problem. That is the problem number 705, and it is the difficulty level is very easy. So let's open this. And here, we will do this in Python, or you can say in Python 3. All right. So we will do in the Python 3 only. And so yeah, that's it. So let's see. So in the binary search, so let's first understand what the binary search is. So search is basically you have to give you have provided some array, or you can a list, and one element is being provided. You have to find whether this element exists in this array or not. That is a search. And at which index. If it is present, then it is at is it which index. So in the Python, we know the index start from 0, 0, 1, 2, 3, 4. So it's on the index 4. So at which index it is present. If it is not present, then we have to return -1. So in the question, it is mentioned given an array of integers numbers. So some array integers number is given, which is sorted in ascending order. So just ignore that. And integer target is given. Write a function. We need to write a function which function to search this target in that particular list. If target exists, then return its index, otherwise return -1. And here the question related to the binary search. So like there are two types of search. One is the linear search, or one is the binary search. So if it is if it is a linear search, so let's suppose you have given a some array, and we have to find some target. So how we will perform the search? We will start a for loop. We will start the for loop from start to the end, and we will start comparing whether -1 is equal to 9 or not. No. Whether the 0 is equal to 9 or not, whether 3 is equal to 9 or not, whether 5 is equal to 9 or not, whether 9 is equal to 9 or not. Yes, 9 is equal to 9. Then we will return its index. All right. So that is like one approach. So which is perfectly fine. It is working like perfectly work fine, and it will return our solution. So basically, we have one approach, that is the linear search. So let's try to write the linear search approach first, because we should know first the linear approach, and then we will go forward with the binary search. So I have created one file binary search, but anyhow we will write two function. So let's rename this function to the linear search. And basically here it is being used the typing concept, uh, Python typing, and it is like they mentioned the num should be list of integer, target should be integer, and return type should be integer. So that is fine. So what is given? We have given a some list, and we have to find the target. So as part of the linear search, what we will do, we will just simple run a loop on a list. So for I in nums. So we can run a loop on the list, right? And then we will compare the particular target to the particular element. So if I is equal to I is equal to target, then we have to return. What we have to return? We have to return the index. So one option is that we will calculate the index, okay, like some variable uh, index is equal to 0, and then as soon as it loop, we can give it +1 +1 +1. But we know there is one inbuilt function in the Python, that is the enumerate, which will automatically calculate the index as well. So it will return two things: one is the index, one is the particular number. All right. So if I is equal to target, so if I miss this target, or we can see this target. All right. So if I is a number, index is index. If I is equal to target, then we have to return its index. right? Otherwise we have to return -1. So that's it. So let's try that. So we have given a numbers, we have given a target, we have given a target, and we have, so so this is a class. So first we have to create an object, then we will like call the function, and in the function we will pass two arguments, numbers and the target, and it will return something, and then we will print that. So let's run. So Python binary search. So list is not defined. So they said that the list is not defined. Here we are using the Python typing. So in the Python typing, so we have to import the list. So from typing import list. So let's try again. Sorry. Name C is not defined. Okay, by mistake I type C here. So it returned the 4. So -1 is at index number 4. -1, sorry, 0, 1, 2, 3, and then 4. So let's search something else, 0. So our output should be 1. So let's search something else, 12. Our output should be 5. 0, 1, 2, 3, 4, 5. Let's search something else, 1200, which is not there. So our output should be -1. And our output should be -1. So that is perfectly fine. So searching is working perfectly fine. But what is the like if in an interview generally they will ask like what is the time complexity, what is the space complexity, and the interviewer expect from us to write a solution which is time efficient, the space efficient. So here, so if you go to the constraint, they have mentioned the length of number could be 1, and it could range up to 10 to power 4. So let's suppose if the length of the number is 10 to power 4, and we have to search the number which is at the last, then we have to run a loop at that number of time, right? So which is not a time efficient solution. So that's why we have another method which is called a binary search. So this solution is related to the binary search only. So in the binary search, so let's first create a function. Def binary search nums, and it will take a list of integer, and target is also integer, and it will like return the integer. So pass. So first thing is like a binary search. Whenever we have to perform the binary search operation, the binary search always perform on the sorted list. Here they have already sorted the list for us. All right, so we don't need to worry. Sorted in the ascending order, only the binary search will be performed. So question is like the binary search will be performed on the sorted list. And how the binary search will be performed? So let's remove this linear search method 1 that is already done. Now the method 2. How the binary search will be performed? So in as part of the binary search, so what we will do is, so let's suppose we have this list which is highlighted like -1, 0, 3, 5, 9, 12. And let's suppose we have to search the element number 0. All right. So list is given. So list is given. So numbers are given. So what are the number? Minus -1, 0, 3, 5, 9, 12. And what is the target? Target is given 0. We have to find, and output should be 1, because we have to return the index, and first index is 0, and the above is the index only. So 0 is at index 1. So this should be the output. All right. So how to perform the binary search? So as part of the in the binary search algorithm, what we have to do is we have to like divide the list basically. So first we will do is we will treat the first element as a start element. We will treat the last element as a last element. right? Last index, and then we will divide it. So once we divide, we will find the mid element. As soon as we find the mid element, then we will compare whether the mid element is equal to our target element or not. So as an example, so how to do that? So let's remove that. Let me remove that. So how to do this? So start is equal to, we will start from the zero. So starting element is zero. That is the starting index. End is the, how to calculate the end. How we know that the last end is, so that is the length of list. So length of the list. So what is the length of the list? 1, 2, 3, 4, 5, 6, 6 elements. So but index is 1 minus. So the end element is 5. So 6 minus 1 is equal to 5. And then we have to calculate the mid. How to calculate the mid? So start plus end divided by 2. All right. So start plus end divided by 2. So what is start here? Start is 0 plus 5 divided by 2. So which is 5 by 2, which is 2.5. So here they are giving, we are giving some like a decimal value, but there is no decimal index. So to sort this issue, what we will do is we will use this float operator, this double operator, which will give us the integer value. So mid is equal to 2. So now, so mid will come. Now we will calculate if our target is 0. 0 is equal to whether our target is equal to, so how to access the element from the list? So if we have to access the element from the list, so number of mids. So the if we have to access the element number 3, how to access? So we will access the element from the index basis. So we have to check, because the mid is 3. All right, so we have to check whether the element which is present at the present mid is 2, whether the element which is present at the index 2 is equal to our target. If it is equal to our target, then we will straightforward its index, and the index is mid. Straightforward, we will return the index, that is mid. But here in this case, target is not equal to mid. So then we will check, okay, if it is equal, our condition did not match, it is not equal. Then we will check whether the target is less than equal to number of nums of bits. So yes, our target 0 is less than 3, right? So definitely we have to search only in this half list, that is only this list. We don't have to search on rest of the elements. So by this way, by this approach, we are like accessing only fewer elements, because the list is already sorted for us. So what we have to do is, so if the target is less than number of mid, yes, target is less than number of mid. So what we will do is start index will remain same, because start index will remain same. So start is start only, right? And end index will be, so what will be the end index? 3 we already checked. So end index will be mid minus 1. Mid minus 1. So now the mid minus 1 is, so start index is start index, which is 0, and end index should be mid minus 1. So mid is 2, 2 minus 1, 1. Right. Now again we will calculate the mid. So which is 0 plus start plus end. Start plus end divided by 2, which is 0 plus 1 divided by 2, which is 1 divided by 2, which is 0. All right. So which is 0. So mid is 0. Then again we will check whether our target is equal to the element which exists at index 0. So no, our target doesn't exist. So here, so so then what next? So our target should be, after that our target is like greater than the minus 1. So if our target is greater than the minus 1, we will increase our starting index. If our target is greater than the element present at the mid, what we will do now, we will increase our starting index. So starting index should be mid plus 1, which is equal to 0 plus 1 1, and index will remain same and is already 1. Then we will calculate the mid. All right, so mid is start plus and divided by 2. 1 plus 1, 1 plus 1 divided by 2, which is equal to 2 divided by 2, which is equal to 1. Then we will check whether the element at mid, always we have to check the element at the mid only. Whether the element at the mid is equal to our target, yes. So mid is 1, the element at one location is equal to our target, which is 0. Then what we will return? We will return our mid. Mid is equal to 1. So the same thing we need to implement into the our logic. So which is very simple. So what we have to do is, so our list is given. So first we have to assign some variable start and the end. So start should be 0, that is the index. The end should be, we know what is the end. End is the here, end is the 6 minus 1. So what is 6? 6 is the length of number, like length of this array. So end is equal to length of nums, which will return us this element, like the whole length. And but index is always 1 minus. So sorry. So it, like and is always like 1 minus. All right. So now what we have to do, so all these things like running in some loop. All right. But we don't know like which loop we have to run, whether it's a for loop, while loop, which loop we have to run. So let's ignore that for the time being. So what operation we have to perform? First, we always have to find the mid, right? Because we know the start, we know the end, and then we have to find the mid. So let's find the mid only. Ignore the loop for the time being. So mid is equal to start plus end divided by 2. So start plus end, and we know we have to use the like double slash operator, other because otherwise like if it is even and odd, it will give in some decimal point. We don't want in decimal point because index is never in the decimal. So mid is there. Then what next we have to do is whether the target is equal to whether the element. So if element at the mid, we have to always calculate the element at the mid is equal to the target. Then what we have to do? Then we have to return the mid, because if it is equal to the element, then the element is at the mid location. The index is mid. Okay. What else? If our element, if numbers of mid, if mid is greater than our target, so target is 0 and mid was 3, right? So our target is less than that, or you can say that the element at the mid is greater than this our target, the element which we have to search. Then what we have to do? We have to search only in this area. So start will remain same, we don't need to change the start, right? We have to change the end. So end should be mid minus 1. If that is this, then end should be mid minus 1. Okay. And what else? There is one more condition. Like in this case, if our target is greater than, then our should be like we will have to change the start. So in this case, so start is equal to mid plus 1, right? And if everything, so this is only one loop, but we don't know how when we have to end the loop. So let's repeat this, and let's suppose we have to find the element. So our target is 15. So if our target is 15, right, what we have to do is start is equal to 0, and is equal to 6 minus 1 is equal to 5, mid is equal to 2, mid is equal to 2. So if the element at the mid is equal to target, element at the mid, target is our 15, is it equal to like a number of like nums of Mid is equal to 2, which is which is which is our 3 is equal to that. No, right, it is not equal. So then we will check whether target is less than what is our target. Target is 15. Whether 15 is less than number of elements at mid, which is 3. No, then we will skip this paragraph. If the target is 15, 15 is greater than the number of element at the mid. What is the number of element at the mid, which is 3. So yes, so our element is greater than the 3, then we will increase our start. So start is mid plus 1. So mid is 2, 2 plus 1 is equal to 3. So mid is 2, 2 plus 1 is equal to 3. Then we have to search only from 3 to 12. All right. So mid is equal to 2 plus 1 is equal to 3. All right. So here mid is equal to 2 plus 1. And end is equal to, our end was 5 and will remain same. Then again we will calculate 5 plus 3 is equal to 8. 8 by 2 is equal to 4. So our mid is equal to 4. All right. So our mid is equal to 4. Then again we will check. So the element at the target is equal to our target or not. So element at mid means 4, that is 9. 9 is not equal to 15, right? So if 9 is not equal to 15 and target is greater than, then again we will increase our mid. So mid is equal to is 4 plus 1, 5, and end will remain same. And mid is equal to 5 plus 10, 5 plus 5, 10, 10 by 2, 5, right? So now this. So now again we will check whether the target is equal to the element at mid. Mid is equal to 5. No. So no. So whether it is less than, no. So whether it's greater than, whether it's greater than, yes. So it is greater than that. So we have to change our starting index. So starting is our 5. 5 plus 1 is equal to 6. And end will remain same. So now our start index crosses our end index, right? So which is, so we have to stop. So basically at what time we have to stop? We have to run a while loop while start is less than or equal to end. Only then we have to run a loop. Otherwise this loop will remain like never ending, because now start is 6. Start is 6, end is previous. So how we can like proceed further? We can't proceed further, right? Because start is like out of index array. So that's why, so loop should be whether the only till that time when the start index is less than or equal to the end. So that's it. If that is fine, and after that we can do return -1. If it is not returning anything, then we have to return the -1. So let's submit that. Let's run that first. So accepted. So now let's submit. So we have submitted the question and it's like it's accepted. We can like see our like execution time by clicking on the graph. So we have beat 79.25% of the like people. We can check the memory. So memory we have beat 97.83. So that is fine because Python is slow. Maybe some people have written this problem in some Java or any other thing. That is perfectly fine. And we have implemented the binary search logic. But here you have noticed one more thing. You must write an algorithm O log and runtime complexity. So we have run our question, we have run our solution, and it is accepted successfully. But how to calculate the complexity? How we know that whether like our solution is running in like log n? We don't know what is log, right? What like we n means like a number of operation, that is totally fine, because if the for loop is running n time, then we say okay, our operation is running like n times. Say, like as an example, in the linear search, so in the linear search we are running n times, so our complexity is big O of n. That is fine. But what is log? Like basically what is log? It is n time, or it is n by 2 times, it is n by 4 times. What is log? So there is a very good explanation here. If you open this website hacker.com, what does the time complexity O log n actually mean? So actually means, so what exactly like we are doing here? So we are So first we have 6 elements, then we have split it into 3, right? Then again we have split it into like a half of the array. Again we have split it into that. So every time we are operating only 1 by 2 operations. All right. So the same thing they have mentioned here. Let's suppose a sorted element has 16 elements, because like the and O log of n is the worst case complexity, is not the best case complexity. We always have to calculate the worst case complexity. So the worst case complexity is like the element should be found at the last only, after doing all the operation. So they have 16 elements, right? And first they have to find the they have to find the number 13. So then first they split the array. So mid is this 7. They have split the array. So one split. Then again they have split the array because 13 is there. Second split, again they have split the array. Third split, again they have split the array. Fourth split, so they have split the array 4 times. So basically for the 16 number of elements, they have split the array into 4 times. So similarly, uh, for the 6 elements, we have split the array into 2 times, basically 2 or 3 times. All right. So for the 16 elements, they have split the array 4 times. So 16 star 1 by 2, 1 by 2, 1 by 2, 1 by 2. Then 2 to the 4 to the 8 to the 16. Right. Then only we can calculate. So what is 16? 16 is the number of element, right? So 1 by 2. And this number could be like a k. Let's suppose 4 is k. So n star 1 by 2 k. So if you do cross multiplication, so 1 into 2 by k is equal to n star 1 is equal to n. 1 multiplied 2 by k is equal to 2 by k. So n is equal to 2 by k. All right. So if n is equal to 2 by k, then we can take log of 2 both the side. So log of 2, log base 2 n, and log base 2 of 2 power k. And we know when there is a power method, then k will come forward and log 2 of 2 is equal to 1. So our complexity is log n. So even if someone will ask in the question, what is the complexity? Okay, we randomly said, because we know binary search run in the log n method, we say log n. But if the person say how to calculate the complexity, so this is the very good explanation. You can go through that. So that's the end of the video. So I think you can also try this question, binary search. So this is very, I think the basic question which generally some interview will ask. So that's it. That's the end of the video. And maybe in the future, we also do some more problems, maybe little dynamic search, trees, so many things. Thank you.